just fold it over, and then I'll save it when we get back to my office.
Why is it missing? Who takes it?
I actually took it by accident last time,
Oh.
because I usually bring my own, and then I forgot to bring it back over, so, it's my fault. But at least I know I'm gonna bring it back eventually.
I sailed my first Texas one, and I was like the most hard to. Since then, the only one up, but. Well, that's the thing. I got all A's in her classes. I was so mad. How's that? Pretty easy to waste the time, isn't it? Yeah.
He goes, for the programming course section, he goes, he just asked you for the function.
Write the function.
Well, then the second one, he goes, write a program that will read from this, and blah, blah, blah. Well, that's not just a function. So I hold that program. But if it's long, but still.
Well,
All you need
answer
is a
portions.
All you need is, he asked for a program, all you need is a function.
Well, that's the problem is, you know, he says, write one that reads a grade output, whether it's an A, B, or C, and then outputs to a file, which outputs your highest, your lowest, and then.
Yeah.
Well, that's a lot more than one function.
Yeah, you need to actually have them, you should have them.
But the way he looks at it, he's like, oh no, you can do all that in one function.
And you can.
That's what he'll say. He'll be like, that's one function.
But I didn't do it that way. He said, write a program,
Just fold the corner over.
You know how it works. So how are you gonna grade it?
He's
Because
not-
so what I did was I wrote it in Visual Studio. and
He let you do that. Wait, did you take it in the test?
Uh-uh.
So you might have to
Okay,
reprint them all.
that's why. That's why, because when you take it in the test center, they will grill you for opening up Notepad.
Really?
You're not allowed to open up
Sure.
anything, yeah. To type, like you have to type in that little text box, they don't let you do anything. It's not fun. They like go in there and they're like, no, you're not allowed to.
Oh, no, yeah.
It's sad.
That's,
You know, like, how am I supposed to write a program?
yeah, I know, it's like, you have an editor for a reason.
Yeah, you're sure.
Well, you usually sit in the back.
I got graded for your midterm. Last semester, I was in computer science. And,
Yes, which has
apparently I'm still signed up for it, so I kept getting these emails like, "Please don't worry." And then finally, my computer board, and then right now, it's like 3% to 0.
This is a new
Really?
I thought it was.
Looks like I had, well, it's, see.
Probably gonna have to talk to somebody about
Well,
that.
it's not due until.
Just the right amount of that.
Why is this, but, I'm sorry, Frank, I apologize.
I
It's
don't know
fine,
if
it
it's
sort of looks like
signed,
you're
but
handwriting.
maybe I'm still
Yeah.
on to an old architect. All of his days were always.
You did that on the exam,
2 years ago.
Well, I write your
All of
name
them
on
do
the
things like, they're 2014.
It's bad.
That's-
Weren't you in like first grade, Evan? And like the first thing they taught you was put your name in the upper right hand corner. Didn't they ever do that?
I was actually in high school when I started doing it.
Really?
I like
Oh,
that.
yeah, I remember I did that.
Whatever, I mean, on the paper somewhere.
I forgot my name. That wasn't fun. She didn't take off points for it, but she was like,
That's what I remember.
she like passed the aggressive and told me like, don't ever do that again. I was like, okay.
Don't do that again.
He said,
I don't
he said, don't ever do that again. but
No, not nice. The master aggressive. Well, okay, whatever. She was.
Yeah.
Now we're adding an arrays. That's what I. Now we're doing arrays. This is all arrays.
This is the problem with our country and obesity.
Oh, no. It's all displayed in that. They want people to get thin in the country and they give us fat youths.
No comment. excited to learn today. Just
So much.
anticipating.
So
Yeah,
much.
I know.
No, it's, I'm just happy, 'cause my next class, I don't have to.
Good for you. My next class is tomorrow at 10 a.m., so I guess I'm kind of happy. It's actually, we just started a new semester for term 2, so all new students.
Which class is that?
It's Math 024. Yeah, well, that's, thank you, sir.
So
We
like
learn about
algebra or something?
exponent rules and polynomials.
Can I do that?
I need to take
Good.
that, I need to take that according.
Anyone's welcome to sit in it. No problems, free of charge.
You know, when I was taking differential equations, because it had been, before I started my math year, it had been.
Okay, guys, so what we're going to do is we're going to move into the next part of the course where we're moving away from any sort of direct proofs or proof by induction. And we're going to start learning about sets, set theory, proofs with sets, but they might not be into the detail of what we did already. And then the other part of this section is learning about counting methods, okay, which most students do really well with, okay? So I think what's left in the course, just to kind of give you guys a heads up as to how much stuff is left in the course, I think we have 5 assignments left, 8, 9, 10, 11, 12, 13, or 12. So that's about 100 points at most you can get left. There's 2 exams left, which are each worth 100 points. The final's cumulative, and then there's another test that's non-cumulative before that. So basically, there's about 300 points
2
left.
exams or 1 exam and final?
Yep. So we have 1 exam and then 1
For
final.
final.
I count the final as the same weight as a regular exam.
Okay.
Okay. So just to let you guys know what's left in the course. So basically, I guess about 60% of the course is written in stone at this point, and then there's 40% left. So there's a lot of time to improve. There's a lot of time to screw up. I guess that's what I'm saying. So hopefully we do the other way and not screw stuff up. So.
How, like, is the rest of the stuff that we're learning, is it just gonna get more difficult?
No, and somebody else asked me this earlier, but the way I think about it is exam 2 by far is the hardest exam, okay? I think exam 3 is somewhere between exam 1 and 2, okay? So it's not ridiculously easy like exam 1 stuff is, where everyone got an A or B, but it's not as tough as the other one. So, so I don't know if that helps or hurts, but maybe gauges it. So maybe that could talk to you about how much you can slack for the rest of the semester. All right, other questions, guys? Okay, so let's go ahead and start with some basic stuff. Let's talk about some of the sets and the set operators, and then, of course, if you guys have some questions, just let me know about stuff, okay? I'm going to assume that some of you guys have seen this stuff before, and then maybe some of you guys haven't, but I just want to talk about some of the different notations when it comes to sets, okay? So 2 of the most basic operations or set are intersection and union, okay? Intersection basically means what's shared between 2 sets. Union basically means I take 2 sets and I smash them together, okay? So basically union means everyone's together, intersection means it has to be shared, okay? Set difference means that everything that's in A but not in B, okay? So basically I just cancel out stuff that's in B and keep stuff that's in A, okay? We'll see plenty of examples of these, okay? The complement of a set is basically everything in the universe but that's going to be outside of the domain A, okay? So basically, if I said females, okay, in this class, that means that all the males would lead in the class, and then that would be the complement of males, okay? So complement basically means if you're a universe, all students in Math 216, then I could divide up the males and females, comp sci majors versus other majors, etc. Okay, sure. Subset, as you guys know, means that if A is a subset of B, every element in A must also be in B. Okay, so basically some shared stuff going on there. And then, basically guys, this just means X is an element of A, means that if X is contained within a set. So, like I said, a lot of this stuff you probably already know, but if not, no big deal. Okay?
Just checking between union and subset. So subset is sort of a check, because it says if true, if all elements, but.
Correct. This is an operation. This is a Boolean, either yes or no.
Got it.
Okay? So this just means, is it valid? This one is always valid. There's always an output for it. Okay, does that make sense?
Yeah.
Okay. All right, other questions, guys? Okay, let's just rip through some of these. They're fairly easy. Most of you guys will do really nicely with them. Okay, so let's say that we have a universe. Okay, so in our class, if we have U, just understand that as the universe, meaning basically the population. We have a set A, 3, 4, 5, 6, a set B, 3, 4, 5, 6, 7, 8, 9, 10, and a set C, 1, 2, 5, and 10. Okay? If I wanted to know what A intersect B is, okay? So what I do is I just look at set A, I look at set B, We need to close that so we can actually see what set B is. That might be helpful. Maybe not. Oh, great. So if somebody were to tell me, what do you guys think A intersect B would be? So, go ahead, Jake.
3, 4, 5, 6.
Okay. So basically set 3, 4, 5, 6. Okay. And notice that A and B both contain 3, 4, 5, and 6, but 7, 8, 9, 10 are only exclusive to B. Does that make sense to everybody, guys? Okay, probably stuff you guys have done a lot. If not, you can see how easy it is. A union C. Okay. Can somebody tell me what A union C would be in this case?
3, 4, 5, 6, 7, 8, 9, 10.
Okay, so,
No,
nope.
no. 3, 4, 1, 2, 3, 4, 5, 6, 10.
2, 3, 4, 5, 6, 10. Okay. I want you guys to notice that 5 is actually shared between A and C, but notice that we only list the element 5 one time. There's no repetition in elements, okay? So once it's stated, it's stated.
Does it have to be in numerical order?
No, it can be in whatever order it wants to be. Just like a sequence can be in whatever, or, I'm sorry, just a list of elements can be in whatever. Okay. B minus A.
Would be 7, 8, 9, 10.
Okay, so all we do for B minus A is we just cancel out stuff that's common between A and B, and then whatever's left over from there, it's good. So we just cross out 3, 4, 5, 6, and then we're left with 7, 8, 9, 10. Does that make sense to everybody, guys? Basically, whatever's shared, you cross out.
If you had A minus B there, then you wouldn't have anything after
That's
that.
correct. So guys, if I asked you what A minus B is, that would be the null set, okay? Which is a set anyway, okay? So when we talk about sets, there's always an output for a set operation.
How do you write the nulls?
A couple ways. You could either write it like this, to where you just have the squigglies empty, or you could just write the 0 with the slash through it, okay?
I didn't get you. Why B minus A is 7, 8, 9, 3, but why is the other one not?
So, because let's say you start with A, okay? So A minus B means that you cancel out stuff. So you would cancel out, if this was A minus B, I'll erase this. You would cancel out 3, 4, 5, and 6, right? So that means that A would be left with nothing in there if it was A minus B.
Ah, okay.
But B minus A, you would have 7, 8, 9, and 10 left over, okay? It's not commutative, okay? So you can't flip the order back and forth and get the same output, okay? All right, other questions, guys, about this? Okay, A minus C. So we start with A. Let me erase this cross-out stuff. So if I started with A, which was 3, 4, 5, 6, and I cancel out the stuff that was common with C, all right, what would be left over for A? So, Jake, go ahead. 3, 4, and 6. The only thing we cancel out is 5, right? So A minus C means that the only thing between common, or that's in common, is just the 5. So we cancel those out, so it would be 3, 4, 6. Does that make sense to everybody, guys? Not meant to be difficult. If I had B minus the universe, okay, what's B minus universe for this, guys?
No.
It would be null
No.
set. In fact, what's anything minus the universe, guys?
Null.
Null set, right? Anytime you subtract the universe, it's always going to be a null set. We could prove that, but we're not going to, okay? So we would just say that it's equal to the null set. Okay, nice and easy, right, guys? Okay. A complement, everything that's in the universe, but not in A. Okay, so does somebody think they might know, or can somebody tell me what A complement might be? for
1,
this
2,
Uh-huh.
7, 8, 9,
7,
10.
8, 9, 10, 11, 12. Good. Good. Okay. Does that make sense to everybody, guys? Basically, your universe is what you start with. That's basically your domain. If you wanted to think of a functional analysis, universe and domain are interchangeable. And then you just cancel out the stuff that's common, or that's not common. C complement.
4, 4, 6, 7, 8, 9.
Yeah. So we have, one more time, 3, 4, 6, yeah. 6, 7, 8, 9, 11, 12, right? Okay. Sorry. So literally, guys, on your next examination, I'll probably have like 2 or 3 of these worth 2 points apiece, okay? They're really, really basic, okay? But they are inclusive of set operations, so I want to make sure you guys are all okay with those. Any questions, guys, about this? Not meant to be difficult, okay? A question that I asked you, and this is sort of what Andre said before, this isn't like this isn't necessarily going to always have an answer, it's a yes or no. So is A a subset of B, why or why not? So what would you guys think?
Yes.
Yes, it is, okay? So we would say yes. Okay. And of course, we need some sort of justification. What's the justification,
They
guys?
share like
All
three.
values are-
All X and A are also in B, right, guys? So we could say for all X that are elements of A, X is also an element of B, right, guys?
Can we just say all elements in A are?
Sure,
in B?
it's the same thing as I just wrote up there. I'm just a
Yeah,
little
I'm just
bit
saying
lazy.
like, I'm just being lazy.
No, that's just, no, actually, I'm being lazy. Because if you actually wrote that out as a sentence, it would take longer than just to write the syntax of what I wrote. But that's okay. And then, obviously, guys, if I ask you part I, what would you guys say for that?
No.
That's false. And all we just need is one counterexample, right? Because remember, to be able to prove a universal statement, you just have to do exhaustion, which we clearly can
Which
see.
is 7.
Yeah, we could just use 7 as a counterexample, right, guys? All we need is just one element, okay? So we would say no. And the reason is because 7 is an element of B, but 7 is not an element of A. Or you could just say, 7's in B, but 7's not in A. Okay, that might work out nicely. Okay? Guys, any questions about these? Okay, like I said, most of you guys have probably seen these somewhere along the line, okay? You might not have seen the set difference, you might not have seen the complement, okay? I'm almost assuming everyone's seen union and intersection before, but if not, okay,